everyone. My name is Tanayati. My register number is URK24AI1077. So today I'll be explaining the Docker and Kubernetes laboratory experiment number 6, control plane and data plane architecture using Kubernetes namespaces. So our aim is to implement a Kubernetes-based network control architecture where a control plane namespace manages configuration and policies. Multiple data plane namespaces act as isolated execution environments like ports, service, devices. Communication occurs via configure maps, services, and API interactions. So the procedures are step one is to create the control plane namespace. This namespace act as the central manager. Uh, Kubernetes create namespace CP to verify Kubernetes get NS. Expected output is name and name will get default in CP. Status we get if it's active, yeah, the default is active, CP is active, and the age is like 10 and 5 as 10 minute and 5 sec. And step two, create multiple data plane namespaces. Each one represent a separate edge or data execution domain. Kubernetes create namespace dp-node 1. Kubernetes create namespace dp node 2. Kubernetes creates namespace dp-node 3. To verify, Kubernetes get NS. Okay, now the step three. Step three is to deploy a control plane manager pod. Okay, so step three is to deploy a control plane manager pod. This pod act as a controller storing configurations. Then file equal to cp-manager.yml. So the API version is v1. Kind is pod. Metadata name equal to cp-manager. Namespace CP. Labels are app cp-manager. Spec is containers. Name manager hyphen name manager. Image HTTPD ports hyphen container ports colon 80. Now deploy it. Kubernetes apply hyphen f cp hyphen manager.yml. Then to verify again Kubernetes get ports hyphen n cp. Now step 4 is to create a configure map in control plane namespace. This stimulates configuration policies for the data plane ports. File cp configure YAML. So API version v1 kind configure map metadata name CP policy is the same. Namespace also CP data policy A log all data plane activity. Policy B report status every 10 seconds. Now apply it. Kubernetes apply -fcp -config.yml. Step 5 deploy data plane ports in each namespace. Each port represents a data plane against fetching control data. The file is dp-agent.yml. The API version is v1. Find is port metadata name dp agent. Labels role a data plane spec containers name dp agent image pc box. Command is this is the command to give a condition while true do echo data plane mode running sleep 5 done. And now deploy all the namespaces. Kubernetes apply -f dp agent yml and dp node 1 same like node 1 we have to deploy the Kubernetes apply -f dp agent yml for -n dp for node 2 and same also go for the node 3. Now check Kubernetes get ports -a grep dp agent. Step 6 create a service for control plane. Expose control plane port for data plane nodes. File cpa-service.yml. Give the API version v1. Kind metadata. The same thing we have explained earlier. So the spec here is selector app colon cp hyphen manager. Ports protocol TCP port is 80. Target port is 80. Now we have to apply it. Um, Kubernetes apply hyphen f cp service.yml. Step 4 is to simulate data plane fetching policies. Exec into a data plane mode. Inside the pod, give this local cluster and step 8 is to observe namespace isolation. And step 9 is to verify the logs. Your control plane logs, Kubernetes logs, and CP manager. Your data plane logs, Kubernetes logs, and TP hyphen node 1 TP hyphen agent. So this is the finalized output we'll get. And the result is using Kubernetes namespaces, the control plane can manage and expose configuration securely, while data plane ports in separate namespace operate independently, ensuring isolation and controlled communication. Thank you.